Imagine you have $1 and want to become a millionaire. You come across a bank that offers you a 10% monthly interest. Now, the question is, how much time you need to become a millionaire? The answer lies in the logarithms. Hi guys, this is Gabriel from Class Heroes, and today I'm gonna tell you about logarithms. And to begin, let's ask ourselves a simple question. How many times we need to multiply the number 2 by itself to obtain the number 8? We know that 2 squared equals 4 and 2 cubed equals 8. So in order to obtain the number 8, we need to multiply the number 2 by itself 3 times. In this sense, we say that the logarithm base 2 of 8 equals 3. I mean, it's the power to which we need to raise the number 2 to obtain the number 8. In general, we say that the logarithm base b of a is the power to which we need to raise the number b to obtain the number a. In this sense, and by definition, b raised to the logarithm base b of a equals a, because, well, the logarithm base b of a is the power to which we need to raise the number b to obtain the number a. There are a lot of properties of logarithms. For example, the logarithm of a product is the sum of the logarithms, and the logarithm of a quotient is the difference of the logarithms, and the logarithm of a raised to the nth power equals n times the logarithm of a. In the description, you'll find a link to a complete list of properties of the logarithms, but for now, let's go back and see how much time we need to become a millionaire if we have $1 and the bank offers us a 10% monthly interest. At the beginning of the first month, we have $1, and by the end of that first month, we would have earned a 10% of that dollar. So by the end of the first month, we will have $1 plus 10 cents, which is the same as $1.1. Now, at the beginning of the second month, we have not 1 but $1.1. So by the end of the second month, we would have earned a 10% of that $1.1. So by the end of the second month, we have 1.1 plus the 10% of $1.1, which is the same as 1.1 squared dollars. The same happens with the third month. By the end of the third month, we will have 1.1 cubed dollars. And if we continue like this, by the end of the nth month, we will have 1.1 raised to the nth power dollars. So, in order to know how much time we need to become a millionaire, we need to find the number n such that 1.1 raised to the nth power equals 1 million. And that number is exactly the logarithm base 1.1 of 1 million. Now, what happens if we don't expect to become a millionaire? We are just saving money because we want to make a trip or buy a car or a bicycle, and we don't need $1 million. We just need $1,000, $100, or $500. Well, while changing these values, we can define a function logarithm base b of x, where b is a fixed number. Okay? In our previous example, b was the number 1.1. Now, for this to be a function, we will consider b to be a positive real number different than 1. And why is that? Imagine that b equals 1. Then which would be the power c to which 1 raised to c equals x? We know that 1 raised to any power equals 1, so x cannot be the number 2, 5, 7, or 9. X must be the number 1. But since 1 raised to any power equals 1, then c, which is not other than the logarithm base 1 of 1, is not well defined. It can be just any number. The same happens if b equals 0. Since 0 raised to any power equals 0, then the logarithm base 0 of 0 is not well defined. Now, what about the case of b being a negative number? Well, the truth is that b can be a negative number, but we have to be very careful because, for example, the logarithm base minus 2 of minus 8 exists as a real number, but the logarithm base minus 2 of 8 is not a real number, it's a complex number. So, in order for b to be a negative number, we will have to be working with complex numbers. To avoid this and have only functions between sets of real numbers, we will consider b to be a positive real number different than 1. So, since we need b to be a positive real number, b raised to any power is also gonna have to be a positive real number. So the domain of this function is going to be the positive real numbers. So this is the logarithmic function. It's a great function. It's continuous, differentiable, it's bijective, its inverse function is the exponential function. It's a very important function in economics or biology, for example, when you need to understand how a population grows. And that's all for today. If you want us to go deeper into this subject or explain any other, just leave a comment. If you liked our video, give us a thumbs up, subscribe. You can follow us on Facebook or Instagram. I'm Gabriel, this is Math Class Heroes. See you next time.